G'day lads, today we're just continuing on with our measurement unit. We've gone through the area of various polygons, so we've gone through the square, the rectangle, the triangle, the parallelogram and the trapezium. And so what I thought we'd go through today is the circle. And we're actually going to use a little bit of the math from the rectangle to actually prove what the area of this circle is. But first of all, we need to remember one thing. What is the circumference? So, circumference. Now remember, if we have a radius r, which is from the center to the circumference, then that circumference is from a previous video we've done was 2 pi radiuses. That means that I can get, if I took that radius, I get 2 pi of them around here, which is basically I'd get 6 and a little bit more, so about 6.28. So with that, can we deduce what the area of the circle is going to look like? And what we're going to do is we're going to do a wee approximation. So what I'm going to do is I'm going to cut the circle up into pizza pieces, pretty much. So let's have a look at that. Oh, we've got 2 there. So I've cut that circle up into little pieces of pizza. And so from the center to the outside, we have a radius, and around the entire outside, we have 2 pi r all the way around the outside. That's the length of the outside, isn't it? So what I could get you to do is then we take all these pieces and we're going to construct a rectangle. So this might take me a little bit of time, but I'm going to take all of these pieces and I'm going to construct a rectangle out of them. Okay, so maybe I should have prepared one earlier. So there we go. You can see the rectangle kind of forming there. This isn't a very good medium for doing this on this paper. So can you see that we are constructing a rectangle out of a circle? Okay, so with all of those pieces getting laid out there, can you tell me what this length along the bottom is going to be? Or better yet, can you tell me what the height of this rectangle might be? So I'm going to have to overlap with that circle a bit. So notice how I'm constructing it. Have a think what the dimensions are going to be. So there we have it. That's all done. So we have kind of approximated a rectangle. So we have a base and we have approximately a height. So we have kind of a rectangle. Imagine if I made these pieces smaller and smaller and I just had lots of little slivers, then this would become less of a parallelogram and more of a rectangle. But even if it was a parallelogram, let's call this the height. This height is roughly equal to the radius, wasn't it? It's pretty much equal to that length there. Because if we made these smaller and smaller, made 1,000,000 of them, then that is going to be the radius. So at the moment, our area has been put into radius. And now, on this side, that's half the circumference, isn't it? That's because all of these curved edges and all of these curved edges add up to the entirety of the outside of the circle, the circumference. So this side here must be a half of the circumference, 2 pi r. If I halve 2 pi r, that would just be pi r, wouldn't it? So we have r times pi r. And you know that the area of a rectangle is base times height. So that's pi times r, which is pi r squared. So the area is equal to pi r squared. Pi r squared. Let's just go through that again. If I took all the pieces of the circle and arranged them into a rectangular shape by alternating the direction of those points, then I would have the radius along here and half the circumference along here, or half that circumference is just pi r. So it'd be pi r times r, which would be pi r squared. And so that is the area of our circle. So without further ado, let's do some examples. So area is pi r squared. So if I wanted to find the area of this circle here with a radius of 5 meters, its area is pi times r squared. So if you're in year 9, that's just 3 times 25, which is 75. If you're a year 9 and above and you've got a calculator, it would be shift pi times 5 squared, 78.5. So I'll do little wobbly equal signs for that one, because the actual area is 78.5. Still an approximation. I guess every time you use pi, you're always going to be approximating your answer, because pi is an irrational number. It just goes on and on and on. What about this one here? So I've done this one. What about this one? We don't have the radius this time, we've got the diameter. So you need to remember that you need to take half that diameter to get a radius. And now I can find the area. So the area is pi times 2 squared, pi r squared. And that's going to be 3 times 4, approximately 3 times 4. So it's approximately 12. Oh, and we need our units, don't we? Centimeters squared for this one. And this one was meters squared. Okay. This one again, we've got a diameter of half a circle and we want just the radius. So we want a 6 millimeter radius on that one. So the area for this one is going to be 3 pi times 6 squared, but we do only have half a circle, so we'll need to divide that whole thing by 2. So I'll do this one on a calculator with pi times 6 squared, then divide that by 2. So we have 56.5 millimeters squared. Now notice I can do area is equal to this is equal to that because it's true all the way through. So that's fine. I would usually go downwards, but I didn't want to run into this one's space. So let's have a look at this. This is a quarter circle because it's got 90 degrees. And so 4 of those would make an entire circle. Make a 360 degree turn. So if we want the area of this thing, we've got the radius. This area is going to be pi times r squared, but we've only got 1/4. So we have to divide that by 4. So I'll do this one with 3. So we've got 3 times 3 squared, so that's 3 to the power of 3. 27 over 4. We could do some short division and all of that, but 27 divided by 4 is 6.75, and that's going to be centimeters squared, and we're done. So that is the area of a circle with 4 worked examples and a little proof. So that might be a nice wee record of learning. Maybe even draw in what you've done to get that area. Awesome. Like that smash button.